What are mosquitoes? Well, they're flying insects, and they're found pretty much everywhere, with the exception of Antarctica. They're part of the Helicidae family, and in fact, there are more than 3,000 species of mosquitoes, so very hard to keep track of. However, what I'm going to talk to you about today are primarily two species in the Aedes genus. Those are Aedes aegypti and Aedes albopictus. The most serious diseases that worldwide are vectored by this genus, with the exception of malaria. It's only females that bite. Female mosquitoes require a blood meal in order to lay viable eggs. And an important fact is that mosquitoes can bite day and night. That's important when it comes to their control. Traditional control in tropical and subtropical regions of Africa have focused on bed netting and the treatment of those bed nets with insecticides. That doesn't work when your mosquito bites you when you're out and about during the day. So a bit about the life cycle of them. I'm going to move away. Hopefully people can hear me. So from egg to adult in about 12 to 14 days. That's dependent on the species, of course. Adults can live between 1 to 4 weeks. Mosquitoes become vectors of disease when they feed on an infected host. This graphic here shows their life cycle. I won't go too much into detail, but an important thing to note here, if you can see that, is that the females laying eggs here, and this is particularly true for the Aedes genus, they lay their eggs above the waterline. What that means is that they're waiting for a rainfall event to wash those eggs into the water before they then begin their larval stage and go through the instars, pupate, and become adults. So very quickly, mosquitoes as disease vectors, they're responsible for up to 1 million deaths each year. Primarily, that's malaria. There's 600,000 associated with malaria in 2022. They infect up to 700 million people per year. Again, primarily malaria, but we'll go on to talk about dengue, chikungunya, and Zika virus that are associated with the Aedes species. It's important to mention that as the climate warms, the season for mosquitoes is becoming longer. There's more areas that they're becoming prevalent in. So yeah, they're expanding their range, and I've got some maps to show that. Before I do so, I mentioned previously that the Aedes genus is the most important from our perspective that we're concerned about, and is one of the most important in terms of vectoring those diseases, chikungunya, dengue, and Zika virus. Now, this gives a picture of the Aedes albopictus spread in Europe. This map's quite concerning, red being established populations of mosquitoes throughout Europe. So you can see they're quite far up into northern France there. There is a little yellow patch here in the UK where they were introduced but since eradicated. This map is a little bit misleading, and I'm not going to be scaremongering people here. This is a more realistic picture of Aedes albopictus in France as an example. So you can see that they are in these northern areas. They have been found in Normandy, but they're not in the great numbers that the previous map suggests. But they're on their way, and they are tracking north, and climate change is enabling that. This is the distribution of Aedes aegypti, the yellow fever mosquito. They haven't started to make that dent into Europe like with Aedes albopictus, but as climate warms in the coming decades, that is something that we're concerned about. What makes Aedes albopictus so invasive is that they are very adaptable, and they have a capability to lay eggs depending on the time of year. So they're photosensitive, they're sensitive to the length of the daytime. When the length of the daytime is shortening, they'll lay different eggs to when it is lengthening. That means that they can survive the winter season. The eggs can also survive a frost, and they're just incredibly adaptable in terms of where they will lay those eggs. They'll lay them in tires, in lots of human settlements. They'll lay eggs pretty much anywhere with a shallow bit of water. This slide's mentioning the disease transmission in Europe. So we've had 130 autochthonous cases across France, Spain, and Italy last year, and you can compare that to just 12 in 2010. So it's a big increase. It's not large numbers, but the increase is big over that 13-year period. West Nile virus, more than 700 cases in 9 EU countries, and that's actually vectored by Culex pipiens, which is a mosquito native to Europe. So what are we looking for? This is Aedes albopictus. You can see here, as is marked out, scutum has this white line, which is distinctive of Aedes albopictus. Aedes aegypti has a different pattern. And I'm just going to highlight a native mosquito, Culecetta annulata, which might be mistaken with the two previous mosquitoes. But actually, when you see them side by side, they are quite different. This mosquito is much more brown. Aedes species are darker in color. They don't have this pattern on the scutum, and the pattern on the legs and body are completely different. So, battery's running low.
Keep going, Nathan.
So what are we doing in Jersey? Well, we are monitoring for the presence of these mosquitoes, primarily Aedes aegypti and Aedes albopictus, as I mentioned. Pictured is a BG Sentinel trap, which has a fan and has a BO scent to it, which the mosquitoes are attracted to. This is in our ports. We also use ovary traps, which are very low tech. They're basically black plant pots with a floating bit of polystyrene in the top of them. As I mentioned earlier, the eggs are laid above the waterline. So in this instance, the polystyrene is where the legs are laid onto. That will never sink below the water because it floats. So it's a good way of monitoring for their eggs. This is what they look like. On the top left-hand side, that is an Aedes mosquito egg. Last year, we had one of our traps return this, and we were quite worried that that might be an Aedes mosquito. It wasn't. It was the eggs of a non-biting midge. So that was good news. But it just shows you, that these traps are effective in capturing eggs of those species. This is very boring. I'll rush over it. Nonetheless important. We have a contingency plan for mosquitoes. This is in collaboration with the UK Health Security Agency, who are the experts in this area, and we've basically designed this to fit into Jersey and Jersey rules. We've shared this with Guernsey, and we're collaborating with Guernsey and the EU on this, and also the ports of Jersey. Important that we know what we're doing if an Aedes mosquito is found on the island. Very quickly on that note then, the contingency plan tells us that we need to set a 300-meter radius from a finding. This is the ports of Jersey where the cars come in at the harbour, 300-meter radius around it. We have traps in here. One of the easy things to do is go and turn over containers with water in them. That stops the mosquitoes from being able to breed. Where you can't do that, then you have larvicides, insecticides that may be of use. Very quickly, what else can we do other than monitor and enact our contingency plan? There's very interesting research that took place in Indonesia that looked at the use of Wolbachia, which is a genus of bacteria that infects insects naturally. They infected mosquitoes in Indonesia with this bacteria and found a 77% reduction in dengue incidence. This bacteria prevents dengue, chikungunya, and Zika virus from developing in the mosquito. and so has an important role to play in our control of them in the future. What else can we do? Increase biodiversity, reduce land use change, mitigate the effects of climate change, and awareness and education, which is what this is all about. Thank you very much.